This is a practice exercise from page 143 in the textbook. We're doing a couple more calculations with molarity, and we're also learning how to do dilutions. So taking a look at this first problem, it's pretty similar to things that we've seen before. They're asking us for a volume, they're giving us a molarity and moles, and we should remember that molarity is moles over liter. So if they are giving us the molarity and they are giving us the moles, it should be pretty easy for us to solve for the volume. The only thing that's a little bit different here is that they are specifically asking about the moles of the lead ions, and I have a whole lead nitrate solution. So what I want to do is make sure I understand what the formula of this solution is. So lead 2 means it's Pb2 positive, nitrate is NO3 with a negative charge. The formula here is PbNO3 2. And essentially what that tells us is that in every mole of the lead nitrate solution, there's 1 mole of lead 2 positive ions. So let's go ahead and do this calculation. Again, we're going to use molarity as a conversion factor. There's a couple different ways to set this up. This is the way I like. You can use any way that works for you. Just make sure you're explaining your steps. So we're going to start with the 0.0500 moles of Pb2 positive. I need to stop talking about moles of just the Pb2 positive and start talking about moles of the entire compound, since that's what the solution is made out of. So I need to know the relationship between moles of lead 2 positive and moles of this entire lead 2 nitrate solution, and it turns out it's just a 1-to-1 ratio, because as we could tell from the formula, there's only 1 lead for this entire molecule. Okay, so looks like a pointless conversion, but we do need the units there, so we have the units changing. So make sure you're including that or explaining that when you do your calculation. So that's going to get rid of moles of lead 2 positive, leaving us with moles of the entire compound, but I don't want moles of the entire compound. I actually care about the volume of the entire compound, and volume is in liters, so I need some information about moles and liters, and that is the molarity, because remember that this molarity here tells you how many moles in every 1 liter. So I know that there are 2.50 moles in every 1 liter. That's going to cancel out the moles, leave me with my answer in liters, and I'm going to have 3 significant figures for this answer, so I'm looking at an answer of 0.0200 liters. And it might make a little more sense to write that as 20.0 milliliters, remembering that there's a factor of 1,000 there. So that's my answer for that problem. However you want to write that. Since it didn't specifically ask us for liters or milliliters, it doesn't matter which one we use. Okay, so that one is pretty standard. We've been looking at problems like that before. The only addition there is thinking about the ions instead of the entire formula of the compound. The next two are a little bit different, and these next two we are doing dilutions. And something to remember about dilution problems is that the moles before equal the moles after. Or the moles you take out of the concentrated solution are equal to the moles in the diluted solution. Because when you do a dilution, all you're adding is water. So what you're adding is you're adding solvent. You are not adding solute. The solute stays the same, which is why the moles before equals the moles after. So the information that they're giving us here is really similar to what they give us before. We are again solving for a volume. This time they specifically tell us that they want it in milliliters, and they're telling us that that volume goes with this molarity. So volume and molarity, if we think back up to this equation, if we're solving for volume, but they give us a molarity, we need moles. And in order to get the moles, we're going to use the information they tell us about this volume and that molarity. And if we look carefully at this problem, this concentration, the 5 molar, that is larger than the 0.1. So this is my concentrated or my stock solution. And then what they're giving me down here, the 0.1 molar, that is my ending or my diluted solution. So I can figure out how many moles are in my diluted solution and use that to figure out how many moles must have come from my stock solution. So in order to figure out how many moles are in my diluted solution, I start with the volume. So that 250 milliliters, I'm going to go ahead and write that in liters. and I can use my molarity to get rid of the liters, put it in units of moles, and I know that there are 0.10 moles for every 1 liter. So what this is going to tell me is that I ultimately need 0.025 moles. So my diluted solution has 0.025 moles in it, so I need to figure out how many milliliters of my stock solution, and these are moles of K2Cr2O7. Okay, so all of this here, this is talking about my diluted solution. But I know that the moles before the dilution are the same as the moles after the dilution. So if I can cancel out moles and turn that into liters, I can figure out the volume of my stock solution. So my stock solution, they tell me, is 5.0 moles per liter. So all of this is my stock solution. And again, notice that the moles in the stock solution are the same as the moles in the diluted solution. So if you do the math here, you're going to end up with a pretty small number, 0.005 liters, which you may want to rewrite as 5.0 milliliters so that you have your 2 significant figures. So what they're telling you is that you needed 5 milliliters of your stock solution in order to make 250 milliliters of the 0.1 molar solution. And this answer should seem reasonable, that we use less of the stock solution since it's more concentrated. Okay, taking a look at the last problem here, again we're doing a dilution. In this case, they're asking us to solve for the concentration of the stock solution, and they're telling us that we get 250 milliliters of that stock solution, and now stock solution might not necessarily be the best term for that because since it's a resulting stock solution, it is actually going to be diluted. But we know that we're starting with 10 milliliters of a 10 molar concentrated solution. We're diluting that so that we've only got 250 milliliters, and again, moles before equals moles after. So I want to try to figure out how many moles I took out of my stock solution. So the stock solution, I had 10 milliliters, which is the same thing as 0.0100 liters. I know that that stock solution had 10 moles in every 1 liter. So I know that I had 0.100 moles of sodium hydroxide. So again, all of that came from that initial stock solution. If the next thing they're asking me to solve for is a concentration is the same thing as a molarity. And again, molarity is moles over liters. We now know that there are 0.100 moles of NaOH. And they told us that the volume is 250 milliliters or 0.250 liters. So 0.100 divided by 0.250, that tells us that the final concentration is 0.400 molar NaOH. And again, this answer seems reasonable because we started with a 10 molar solution and we diluted it, so our final answer should be less concentrated. We should have a smaller concentration at the end. Again, there are a couple different ways you can solve these problems. As long as you're explaining your answers and they make sense, you do not have to solve them the same way. I know I solved them a little differently from the textbook. Just make sure you understand why you're doing all the steps and you can write explanations.